Hi Kimberly. I decided to make a video to explain systems of equations, which is the next concept I wanted us to talk about. Um, it's a really useful thing to have because there are lots of questions that come on standardized tests that would require this method to solve them. Um, there are three main methods. You have your graphing method, you have the substitution method, and then you have the elimination method. Elimination would usually be the fastest, and this is the one I recommend that you apply first in any test. Substitution is my favorite. I think I like playing with numbers sort of, and this sort of helps me. The graphing method is the most instructive in regards to what exactly is happening when solving a system of equations, but you would rarely use this in an exam. So let's go. Let's dive right into it. I'll try to keep the video as short as possible. I don't know if you like the music in the background, but sorry. Okay. This is a system of equations, and these are linear equations. Linear meaning that they represent straight lines, and one way you can tell is by looking at the variables. They each are to the power 1, so they're not squared or cubed or square rooted or anything like that. It's just to the power 1, so we know that they are linear equations. So what is happening here is that you have two straight lines and you're trying to figure out where they intersect. That's really what's happening for a system of equations. You're trying to find out where the lines intersect, and there are three possibilities. One of them is that both lines can intersect at one particular point, which is typically what you would get on tests. And then you can also have a situation in which both lines are parallel, and as such they will not intersect, and you would have no solution. And then the final option would be that both lines are identical, and when they being identical, you would have an infinite number of solutions because they're exactly the same. So let's start. For the graphing method, it's best to rewrite the equation in point slope form. So I'll take the first equation, so that's 2x minus y is equal to 1, and I want to rewrite this in point slope form. So I would subtract 2x from both sides, so I have negative y is equal to negative 2x plus 1, and then I multiply both sides by negative 1, so I'll have y is equal to positive 2x minus 1. First equation. Second equation, we have 3x plus 2y is equal to 12. I'll subtract 3x from both sides, so 2y would be equal to negative 3x plus 12. And then we'll divide both sides by 2 so we can have y on the left hand side. So we'd have negative 3 over 2x plus 6. I'm dividing both terms. So these are these equations in point slope form. Remember, not point slope form, slope intercept form. That's our slope and that's our intercept. And this is the easiest way to graph it. Since I'm using, I have my phone or the camera in one hand, I'm just gonna draw rough lines with my right hand. So this equation is 2x minus 1, y equals 2x minus 1. So our slope is 2 and our y-intercept is negative 1. So we always start from with the y-intercept. So I'll go to the y-intercept and it's at negative 1 and the slope is 2. So rise 2, run 1. And I can go again, rise 2, run 1. And one more, rise 2, run 1. So I'd stop there. I don't need too many. So it should be something like that. That's the first line. So this is the line y is equal to 2x minus 1. And the next line would be, I'll start at 6, so 1, 2, 3, 4, 5, 6. That's my y-intercept. And then the slope is negative 3, 2. So my rise, which because it's negative, I would go down. It might be what I'll say. I'll call it a drop instead. So a drop of 3 and a run of 2, a drop of 3 and a run of 2. So this would look like this instead, and this would be the line y is equal to negative 3 over 2x plus 6. And as we can see from here, the solution is right here. This is the point 2, 2, 3. and that's the solution of this system of equations. If you had a graphing calculator, you can do it directly, but typically that's not what you would do on the test. You would do elimination, as I mentioned. So let's look at substitution really fast. So a substitution, you would solve one equation for a variable and then plug it into the other equation. And it's preferable that you take the simpler equation and solve for a variable. So looking at this one is a simpler equation, so I can use this to solve for y and then plug it into this. Instead of doing this all over again, we have already solved for y up here, so I'll just copy that down. So y is, as we said, 2x minus 1. So I would put this in place of y in the second equation. So 3x plus 2 into 2x minus 1 is equal to 12. So 3x plus 4x minus 2 is equal to 12. I can combine like terms. These two are like terms. So 7x minus 2 is equal to 12. And then I can add 2 to both sides. So 7x would be 14. And divide both sides by 7, so our x value is 2. So that's so we have an x value, and then I can take this and put this in here. This is, I mean, usually the easier way to do it, and I can put it back in here to solve for y. So y would be 2, and then I'll replace the x with 2 minus 1. So this would be 4 minus 1, and that's 3. So the solution here, points are written to form x, y, so our solution would be 2, 3. Okay, now let's move on to, so this is the substitution method, and let's go on to elimination, which I believe is the fastest. So what you do is you write both equations down. Sorry, I wrote that wrongly. So that's 2x minus y is equal to 1, and then we have 3x plus 2y is equal to 12. Okay, so what I want to do is I will want to write them in such a way that, or look for the LCM of the numbers either. I mean, and it would depend on the variable I want to eliminate. So let's say I chose to eliminate x first. So if I want to eliminate x first, then the LCM of 2 and 3 is 6. So I'll ask myself, what would I do to this to get 6? And what will I do to this to get 6? So for the first equation, I'll multiply everything by 3. And for the second equation, I'll have to multiply everything by 2. So I'll end up with 6x minus 3y is equal to 3, and 6x plus 4y is equal to 24. And I've seen people do it sort of differently, but I like doing it this way, and then I can just subtract. I subtract the entire second equation. So 6x minus 6x is 0, so that goes away. And then we have negative 3y minus positive 4y. So we're just subtracting that. So this would be negative 7y. And then we have 3 minus 24. So this would be negative 21. So when we divide both sides by negative 7, we get y is equal to positive 3. So that's that one. And then we can go back and do sort of a substitution from the other method. So in either case, we're going to do some sort of substitution if we're doing even in elimination. I prefer to pick this equation because it just looks easier. So 2x minus 3 is 1, so 2x is 4, and x is equal to 2, dividing both sides by 2. So again, our solution here is 2, 3. So all three methods yield the same solution. That's 2, 3, that's 2, 3, and that is 2, 3. So these are all three methods. On the test, you would preferably use this one. Problem will usually be given to you in word form. You would change the word problem into a system of equations, and then you would solve the system of equations by elimination to get the solution. Thank you. I hope this helps. I'll send you a few practice problems, and I'll probably do another video which shows you how to apply that in solving word problems. Thank you, and God bless.